My project to replace the controls for the 82-inch dome shutter and curtains is now complete, and everything is fully functional. This rebuild entailed replacing everything, starting from the console switches, which are now inoperative, and ending at the motor leads on the dome. Most observers will now control the curtains and the dome slit through Track 82. However, there is a manual control station next to the bridge. We'll get to that in a minute. In the future, I may restore functionality of these switches by installing a Raspberry Pi inside the console. The communication link between Track 82 and the control systems on the dome is made through a dedicated pair of wireless bridges. The first one is located on the top of the North Pier, and the second one is here at the top of the stairs. These wireless bridges are separate from the dome Wi-Fi. The low voltage control station is located next to the bridge, and it features manual override switches, which can be used if Track 82 is not operating or there's a loss of communication. Inside, there's a schematic diagram which details the construction of the entire system. The update needed for the electronic shop is particularly easy. Just rip it all up. None of the old equipment exists at all. There was no way to remove the subpanel containing the contactors for the dome and the shutter without resorting to dissection. Along the way, I made many discoveries. These are the overload protectors for the dome shutter and the curtain motors. Neither of these overload protectors were actually connected to anything. Now, the motors for the lower curtain, upper curtain, and dome shutter have phase and overload protection. If those devices trip, these indicator lights will come on. All of the high voltage, high current equipment is located in this enclosure. These are the reversing contactors for the lower curtain, upper curtain, and shutter. Their 24-volt coils have a dedicated power supply. The other 24-volt power supply is dedicated to the PLCs and communication equipment. Each motor has an overload and phase protector. In the event that there's an overload or a loss of phase, the yellow indicator flag will show under the window. There's also a blue reset button for each one of these, and under the window there's a red test button so that you can make sure that this is actually working. The scope of this project did not allow me to fix every electrical problem that I found. For example, in many places, transformer neutral and dome earth ground are connected. However, I fixed every problem I found associated with this project. This is the sub-enclosure for the main breakers on the dome. The slip rings come directly into this panel, and then this distributes power to the motors and the lights. In the old system, the power wires for the dome shutter and the curtains came through this hole punched in the top of this enclosure. There was no cable gland, and these edges are sharp. And you could see where these edges had abraded the jacket on the power wires. So this is a live wire coming out, and it's the wire for the lighting system. So that's another project for another time. Similarly, the limit switch wiring was bare. It just came in through holes punched at the top of the old contactor box. And I think this was the source of the problem. This area has been inundated by water and oil in the past, and bugs. And these things would just come in through these holes punched at the top of the contactor box and coat everything inside, the electronics, the magnetic contactors, the relays, everything. In the winter, when you tried to open the dome shutter, if it opened at all, you would hear this thing buzz. And what it was doing is cooking that polymerized oil, which had turned into varnish, until it softened enough to conduct electricity. So I think it was wise just to throw the whole mess out. It served well from 1963 until a few years ago when these problems really started with the curtain runaway and the dome shutter not opening. So I'm not complaining. This is the limit switch wiring today. So instead of just bare wires coming into holes in the top of an enclosure, everything comes in through cable glands into a sealed enclosure. This cable gland and this 15 conductor wire go out to the control station that we just looked at. The last thing to do is to re-enable the dome e-stop system. When Logan, Joshua, and I were dissecting the old contactor box from the dome, we discovered this black mystery wire. This is the e-stop wire. It has a dedicated slip ring connection to the magnetic contactor in the old control room. So if you ground this thing out to the dome, probably because the dome is connected to transformer neutral, the contactor opens and the dome power goes off. I now know which of the two wires I need to grab from this bundle that I had to cut off. And I'll also put a bypass switch underneath this enclosure. And I also bought 3 e-stop switches, which I will place in strategic locations. I know that one of them will be by the manual control station next to the bridge. And one could be over here by the mezzanine work area. And a third could possibly be placed on the opposite side of the dome. My next project in this cycle concerns Pro-EM. For many years, all observers have suffered an intermittent problem where Pro-EM refuses to trigger the next integration. The trigger signal originates from the Trimble clock unit in the control room, and it travels over the 75 ohm coax cable. In the past, this BNC connector attached to this swiveling BNC connector that was strapped to Pro-EM. And the theory was that as the telescope tracked from east to west and as it slewed to new targets and this umbilical moved, that the cable could rotate in this BNC connector. It could swivel in this. But the problem is it doesn't have enough degrees of freedom, because sometimes the umbilical would want to twist it about this axis. And I think that's what was causing it to disconnect or develop an intermittent connection. Observers would come out here and they would just touch this swiveling connection, and that would restore triggering. Or sometimes they'd have to unplug it and plug it back in, and that would restore triggering. And sometimes they would do both of those, and then the camera would crash. So my solution is to make the connection to this coax cable with this BNC connector that goes to a 3 gigahertz microwave ready flexible coax connector that goes into the miniature micro MCX connector on the underside of Pro-EM. So the only thing that's not quite kosher here is that I just used gaffer tape to attach this cable so that we can't rotate this MCX connector. So perhaps something a little more industrial would be in order here. But this has solved the triggering problem completely. So I consider this case closed.